All right, thanks for tuning in today. You know we've been talking a lot about triangles, so I have a special activity here designed for you to take a look at triangles. What you need, piece of scratch paper, I think printer paper would be best, scissors, a ruler, and a pencil. So here's what I want you to do. I want you to cut out a triangle from your scratch piece of paper. Okay. You'll notice I've already done that. Okay. So it does not matter to me if the triangle is an acute triangle, a right triangle, obtuse triangle, any triangle. I would suggest not making it extremely large or not making it extremely small. This is the size of mine. That'll be sufficient. So go ahead and pause this video and make this triangle, and when you're done, turn the video back on. Alright, so you've got your triangle, I've got mine. What I want you to do next is to use your ruler, okay, and find the midpoint of each side of the triangle. So I'm going to use my ruler, I'm going to measure the length of each side, I'm going to find the midpoint, and I'm going to put a mark. Okay. I've already done that. And just darken up these marks here a little bit so maybe you can see them. Oops, there it goes. Okay. So I have marked the midpoint of each side. Go ahead and pause this video. When you've got that done, go ahead and start it back up. Okay, so let's just draw a quick sketch of what you've done. Okay, you've cut out a triangle. Okay. You have found the midpoint of each side. So you have a mark somewhere, maybe there. Here, let's do this. Okay, so you've got a mark at that midpoint, this midpoint, and that midpoint. This is just a quick sketch. Okay. Don't judge me on it. So now that you have those markings, what you're going to use is you're going to use your straight edge, and you are going to draw a segment that goes from the midpoint to the opposite vertex. Okay. Again, use your straight edge, draw a segment that goes from the midpoint to the opposite vertex. This is a new type of segment. Notice it's not a perpendicular bisector. It's not an angle bisector. This is called a median. And this is one of the medians of the triangle. So okay, take your ruler, okay, line it up, midpoint to opposite vertex, draw that. I want you to do that for all three of them. Go ahead and pause the video. Alright, so if you've finished, okay, you've got your triangle, you drew all three medians of the triangle. What did you notice happen? Just to make this easier to see, I'm going to open up GeoGebra. Hey, there it is. It's working. Wasn't working a minute ago. Okay. And let's just redo this construction quick so everybody can see this. So there's my triangle. I'm going to find the midpoint of each side. There's my midpoint tool. And I'm going to draw a segment from the midpoint to the opposite vertex. And we see, for the third day in a row, that these special segments have a point of concurrency. We have this point right there. Okay, they agree at that one point. Is this point the circumcenter? Well, let me grab a circle. Is it the circumcenter? No, it's not. Is it the incenter? Does it just go to the sides? It's not the incenter, is it? Okay, this point has a special name. It's called the centroid. Okay. The point's called the centroid. So what's special about it? There's no circle, is there? Okay. Well, you just found the centroid of this piece of paper. What I want you to do now, okay, is I want you to take and balance this triangle on the tip of your pencil. Okay. Now, I have not cheated. I just made this triangle. I cut it out before the video, okay, but I've been doing this with you. Okay. But let's see if we can balance the triangle on the top of the pencil. And there we have it. Okay. And where is that triangle balancing? Right on the centroid. And there it goes. Okay. So go ahead, pause the video. Hopefully you can get it to balance quickly. When you've got it to balance and you're ready to go ahead and start this video back up. All right. Well, that was fun. Kind of a cool thing there, balancing a triangle on this special point. We now know how to do that, don't we? Okay. So we got a cool trick to show your family when you get home tonight. I'd suggest keeping this triangle. But let's think about this a little bit more. Why is the triangle balancing on that point? What has to be true here? Hey, think about this. Look at the diagram. If I'm balancing on that point, what has to be true? What makes something balance? Well, that the weight is evenly distributed, right? So as I take a look at this, if the weight's evenly distributed and I'm balancing it on this point right here, what does that mean about this triangle? What does it mean about that triangle? It means they'd have to weigh the same, wouldn't they? So are those two triangles congruent? Okay. Is that triangle, let's see here, is that triangle congruent to this one? Well, they're not congruent, are they? But they have to have the same weight. Now, if this is a uniform thickness, the thickness of the paper doesn't change. So, if they're going to have the same weight, though, they at least have to have the same area. Okay. So I'm wondering if we can find the area of this triangle. Area of triangle ABF, 14.59. How about the area of this triangle over here? Area of triangle BFC using my area tool, 14.59. They're the same area. Well, not only is that going to work for those two triangles, doesn't it also have to work for this triangle here and the triangle below it? Area of triangle DBC, 14.59. That number sounds familiar. Area of this triangle, 14.59. Wow. Okay. And how about our last triangles? Which ones haven't I done? I think I haven't done this one. And that one. So area tool, we see that. So our centroid, in a very, very cool way, pretty simple way, splits this into triangles that have the same area. And in several different ways, that's why it balances perfectly. So that's a cool thing about the centroid. Now there's one other thing that's going to happen here, and it has to deal with distances. And that shouldn't surprise us, because when we found the circumcenter, it was the same distance from the vertices. When we found the incenter, it was the same distance from the sides. What's the distance component of this one? Well, I'm going to measure this, and I'm going to measure that. Okay. And let's see if we notice anything. Let's see if I can get some nicer numbers here. That's getting pretty small. Let's go bigger. There we go. Excellent. Okay. So take a look at this. When we've got this special point called the centroid at the point of concurrency of the three medians, it splits each median into a ratio where we notice that this distance is twice as long as that distance. In other words, GF is what fraction of the entire median? It's 1/3. This is 1/3 of the median. That's 2/3. This is double that. So we've got a lot of things that we talked about with our centroid. Okay, so let's jump to our notes, okay, and write some of this stuff down. Where are my notes? There they are. All right, so a median. Is a segment. Whoa, got the big pen on still. A segment connecting the midpoint of a side of a triangle to the opposite vertex. Okay, I missed another vocab word I wanted in here. And I closed my notes. Here we go. Let's find it. There it is. Okay. So the centroid then. Okay. Okay. This is the point of concurrency of the three medians of a triangle. Okay. You might also want to put a note in here. This is the balance point. Now, an interesting thing here is centroid is a term that's actually used in geography when talking about different regions, whether it's countries, states, counties, and so on. They use the centroid to describe where the center of that region is. So it got me wondering, what's the centroid of Minnesota? If I were to print off the state of Minnesota, cut it out perfectly on a piece of paper where the thickness is even across the entire paper, if I were to cut it out, balance the state of Minnesota on it, where in Minnesota would it be? Well, I used our friend Google here, and I typed in centroid of Minnesota, list of geographic centers of the United States. Okay. So centroid is the geographic center of a region. Okay, so I'm looking down here, Minnesota. The centroid of Minnesota is in Crow Wing County, 10 miles southwest of Brainerd. Wait, 10 miles southwest of Brainerd. Where would that be? Well, I pulled up a map here. There's Pillager. There's Brainerd. If I was driving Pillager to Brainerd, 14.4 miles. So that would put 10 miles southwest of Brainerd about where? Okay, now it didn't give us super detailed here, but 10 miles southwest of Brainerd, we're not sure exactly if it's perfectly southwest or what, but I would say, let's see, that's 14, 10's probably about here. We're talking right around that region down by Crow Wing State Park. Isn't that interesting? Okay. geographical center of the state. Pretty close to Pillager. Okay, in fact, Pillager might even be closer than Brainerd. All right, so concurrency of medians of a triangle. The medians of a triangle intersect at a point that is blank of the distance from the vertex to the opposite side. So they meet at this point, which is called the centroid, which is the balance point. Okay. What's the distance thing again? What did we learn back in here in GeoGebra? Okay. That it meets at a point that is what fraction of the distance from the vertex to the opposite side? From the vertex to the opposite side. This point is 2/3 the distance from the vertex to the opposite side. Okay. That's 2/3, that's 1/3, this is double that. There's a lot of relationships that we can write. BP is 2/3 of BF. FP is 1/3 of BF. We could also say that BP is 2 times FP. That's the relationship there between those distances. So what I'd like us to do next, okay, is if I give you the vertices of the triangle, I want you to find the centroid. So we've got the point J at 1, 2. I've got the point K at 4, 6. There's K. L is at 7, 4. There it is. So where is the centroid of this triangle? Well, how do we get the centroid again? From the medians. Well, if I'm going to draw a median, I need to know the midpoint. So let's first find the midpoint of JL. Remember the midpoint formula? Let that be x1, y1. I'll let that be x2, y2. So our midpoint, I'll call it M. Remember, it's the average of the x's and the average of the y's. Okay, let's see, that's 8 divided by 2, which is 4. That's 6 divided by 2, which is 3. Our midpoint M is at 4, 3. 1, 2, 3, 4. 1, 2, 3. Right there. And that looks right, doesn't it? Okay, so let's draw in my median. Midpoint, opposite vertex. So I know my centroid is somewhere on that median. Now I have a couple options here. I could find the midpoint of the other sides and find where they cross, or I could remember the relationships that we have here. That the centroid is 2/3 the distance from the vertex to the opposite midpoint. How far is the vertex from the opposite midpoint here? That's 3 units, isn't it? What's 2/3 of 3? 2. So that tells me that the centroid is 2 units from the vertex to the opposite side. Okay, so 2 units. So 1, 2, right there. Is that where we'd be able to balance that triangle? No, we know that wouldn't balance there. We need to go 2 units from the vertex, the opposite midpoint. That right there is our centroid. All right, we're going to keep cruising with special segments in triangles. Next up, we've got an altitude. Now, I'm sure you've heard that word altitude used before, and I'm sure you've used it referring to the height. Okay? So altitude has to deal with height. So how do we get an altitude of a triangle? If I draw a triangle that looks like this, where would be its altitude? Okay, what would be its height? Well, we would go from there straight down. Now, what do we mean by that, going from there straight down? It means we need to be perpendicular. Okay? The height, or the altitude, is a segment that goes from the vertex that is perpendicular to the opposite side. All right, let's explore this a little bit. Let me make a triangle. And let me make the altitudes. So I'm going to use my perpendicular line tool. I need to be perpendicular to this side, but go through that point. There's that altitude. Now let me do the same thing for our next altitude. From this point, perpendicular to that side. And for my last one, I'm going to go from this vertex and be perpendicular to that side. And what do we see? We see a point of concurrency again. 4 times in a row with these special segments, we've seen a point of concurrency. There's no special circle thing. Okay. This is not the centroid. It's not a balance point. This has really, honestly, nothing that special about this point. Not the balance point, not the centroid. Doesn't have the circle things. The coolest thing about this point is that it exists. Now, I do want to move this around a little bit to show you that this new point called the orthocenter doesn't have to be inside the triangle. Okay, we saw the circumcenter went inside and outside the triangle. The incenter had to be inside. The centroid, that has to be inside too. If we're going to balance a triangle, the point has to be on the triangle. Okay, but this orthocenter can be outside or inside. And we see something kind of interesting happen here, particularly when I do it like this. The altitude, this line right here that's going mostly vertical, is an altitude. But that altitude, that height of this triangle, isn't even in the triangle. How can the height of a triangle not be in the triangle? Well, what are the requirements again? We have to go through this vertex and be perpendicular to that side. Where's that going to happen? Well, that's only going to happen when I take my side and I extend it out. Okay? It intersects right there. So our altitude does not have to be contained with inside the triangle. Okay? You have to extend the sides. So with that, the orthocenter is the point of concurrency of the 3 altitudes of a triangle. Okay. Concurrencies of altitudes of a triangle. The altitudes of a triangle are concurrent. Put a note here. This is called the orthocenter. We can see it right there. We see the 3 altitudes. They meet at that point A. Again, there's nothing too special about this point. Like our other points, it just exists. So here's how I'm going to wrap up this video. Do you see these triangles down here? And I have special segments drawn in each of these. Okay? All these BDs. Okay? What I want you to figure out is for each of these diagrams, is BD a perpendicular bisector Is it an angle bisector? Is it a median? Is it an altitude? Or possibly a combination of all of them? So I'm going to end the video here asking you to go through each of these and identify for each segment BD which of those it is. And next time I will see you, we'll check it. Okay. So with that, don't forget your new magic trick on how to balance a triangle. Okay, we've got centroids, we've got orthocenters to go along with our circumcenters and incenters. There's a lot going on. This has been fun to see what happens. We'll see you next time.